The topic of this video will be the selective reduction of aldehydes. Remember that aldehydes are more reactive than ketones. Aldehydes are more electrophilic. This is because the ketones have more of an inductive effect, helping to stabilize the partial positive that forms at the carbonyl carbon, because the neighboring groups to the carbonyl carbon in a ketone are carbons, whereas in an aldehyde, one or both of the neighboring groups to the carbonyl carbon are hydrogens, which cannot donate electron density through the inductive effect. Therefore, the carbonyl carbon of an aldehyde is more electrophilic. Remember that most of the reducing agents we've discussed are hydride donors, where hydride is acting as the nucleophile. Because an aldehyde is more electrophilic than a ketone, if we use a less reactive reducing agent, we can reduce aldehydes in the presence of ketones. A less active reducing agent will only react with the more reactive electrophile in the aldehyde. The reducing agent that's typically used to reduce aldehydes in the presence of ketones is sodium triacetoxyborohydride. Typically, this reducing reagent is abbreviated like this, and its structure looks like this. Sodium triacetoxyborohydride is a weaker hydride donor because of the electron-withdrawing acetoxy groups. Because it's a weaker hydride donor, it is therefore less reactive and will only react with the more electrophilic aldehyde and not the less electrophilic ketone. This allows us to use this reagent to reduce aldehydes in the presence of ketones. For example, if we treat this molecule with sodium triacetoxyborohydride in an alcohol solvent, just like we saw for sodium borohydride, we will see reduction only of the aldehyde, not the ketone.